we're going to be going over trigonometry. Trigonometry is a very interesting part of maths. And the easiest way to understand this is by drawing a unit circle. A unit circle is just a circle which has radius 1. Okay? As you can see, I've written 1 here and 1 there, 1 there, 1 there. Okay? Now, say from the center, the origin is the center, a random line going to the circle. Okay? Now, obviously, this is going to be of length 1 because it's a unit circle. But how do I find the coordinate of that point? Okay? So what I'm asking is, how much along do I go and how much up do I go? Now, this obviously is dependent on where that line I draw is. As you can see, this height is different to this height. Okay? And even if it's on this side, then this length is going to be a negative length. And this height is slightly less than this height. So it's clearly dependent on where I draw this line. Okay? Now the location at which I draw this line can be determined by the angle it forms. So this is theta. Theta. Okay? Now, if I wanted to find the length along the x and the length along the y, I can solve this by using trigonometry. Okay? Now, always the opposite of the angle. So the height is going to be, let me zoom in a bit more, sine theta. Okay? And this length right here is going to be cos theta. Okay? So, if I was asking you what the coordinate of this is, it's going to be cos theta sine theta. Okay? Now, this is going to be true anywhere along the circle because my coordinate is dependent on the value of theta. Now, what this also means is that I'm going to draw this in blue, if my line to the circumference was straight up, then theta would be 90 degrees. So that means the coordinate that it lands on would be cos 90, sine 90. And we already know the coordinate of this location, which is 0, 1. 0, 1. This means that cos 90 is 0 and sine 90 is 1. And this also makes sense because, as we said here, sine theta is going to be the height, and right now the height is 1. And cos theta is the width, and the width is 0. Okay? This is how you understand basic trigonometry, sine theta and cos theta. I'm going to quickly go over that again. We have a unit circle, okay, and we have a radius, okay, and it's going to be of length 1. Now, when we have a triangle of length 1, and we know that when we have a right angle triangle, remember this has to be right angle, should have mentioned that a bit earlier. When we have a right angle triangle, and the hypotenuse is 1, okay, and we have labeled one angle as theta, the opposite side length is always going to be sine theta. And the adjacent, we call this the adjacent, the one where it says cos theta. So in blue, we have the adjacent. The sine height is known as the opposite. That's the opposite height because it's opposite the angle. And the cos length is going to be the adjacent. The adjacent. Now, and obviously this is called the hypotenuse, the one side. Okay? by using this principle, we could work out both legs of a right angle triangle as long as we know one angle. So the hypotenuse is 1, and I have an angle of 60. Okay? That means this side is going to be cos 60, because it's the adjacent, and the opposite is going to be sine 60. Now, bearing in mind, this is only true if the hypotenuse is length 1. Okay? And if you put this into a calculator, or if you know if you've memorized like trigonometry, like the trig values of certain angles, you know that cos 60 is 1 over 2, and sine 60 is root 3 over 2. Okay? Now, because it's a right angle triangle, you can apply Pythagoras' theorem. So let's do that to this triangle right here. Root 3 over 2 squared plus 1 over 2 squared should equal 1 squared, which is just 1. This means that 3 over 4 plus 1 over 4 is equal to 1. As you can see, this is true. But that also means, in general, sine theta squared plus cos theta squared is equal to 1 squared, which is just 1. Now this is a very famous and useful trig equation. Okay? Anyways, let's see how you find the legs of other triangles. Okay. Say this time the hypotenuse is 2, and this time theta is 30. Okay? Now, again, the opposite is going to be sine theta, and the adjacent is going to be cos theta, right? However, this time, the hypotenuse is 2. So if you think about it, I am just scaling the side lengths. So I'm just scaling, doubling the side lengths. I'm just scaling the side lengths by 2. If the hypotenuse is 1, it would be a smaller version of the exact same thing. And it would be smaller by a half. So because I'm just scaling up the triangle by 2, I'm just timesing both side lengths by 2. So this time it becomes 2 cos theta, and this becomes 2 sine theta. And in this case, it's 2 sine 30, and the adjacent is 2 cos 30. Okay? So, if I wanted to create a general rule for what are the legs of a right angle triangle, it would be sine is going to be 2 hypotenuse, so HYP times sine, let's just write times sine 30, so let's do theta, is equal to the opposite side. And this refers to the opposite of where angle theta is located. Now if I do the same for cos, I would be doing the hypotenuse times cos theta is equal to adjacent. Now these are the general rules, and I can rearrange this to write sine theta is equal to opposite over hypotenuse, and cos theta is equal to adjacent over hypotenuse. Now, let's talk about tan. Okay? So let's say I've just done this. Now remember, this is theta, this is 1. This is going to be sine theta, this is going to be cos theta, right? Now, tan theta is going to be the length of this height of where, when I extend this, these points meet. Does that make sense? It is going to be this height. I could just label this as tan theta. This height is going to be tan theta. Okay? Now, what is interesting here is that we know that this full length is 1. So, really, if we do rise over run, we found the gradient. So tan theta over 1 is the gradient of this, right? So basically, tan theta just represents the gradient. Tan theta equals the gradient. Okay, because the base here is of length 1. So when we do rise over 1, we get tan theta over 1. Okay? So if tan theta is the gradient, we also know that if we do rise over run, sine theta over cos theta is also the gradient. This means that sine theta over cos theta is equal to tan theta. Okay? This is another very famous equation. But I want to point out something very important here. If the angle of theta is 90 degrees, so in other words, it is going, I'll do it in blue, it is going straight up, okay, then these two lines will be parallel. So they never meet. AKA, the length of this blue line right here would go on infinitely. So in that case, so you'd write tan of 90 is undefined. And this also makes sense when we link it to the gradient point. Okay? Because what is the gradient of a line going straight up? We can't divide by 0. So again, it is undefined. That will be all for today. We'll talk about trigonometry in future videos. Don't forget to like and subscribe. Thank you.